Hi, welcome to Layman's Guide to Cracking the Coding Interview. I'm Jox, and today we're going to be solving finding the target in the 2D array. So here we have, the given input would be the sorted 2D array. So it's a sorted, so let me highlight a little bit bigger. So it's a sorted 2D array matrix, and we need to find the target value. So we have a target as a 30, and it's a sorted, as we could see, 1, 3, 5, 7. And then it's in an increasing order, then 10, 11, 16, 20, so forth. So we need to find the target value as a 30. If the value exists in this given array, then we return true. If not, then we just return false. So in this case, we can think about as a 2D, as a simple 1D array. So when it's sorted, we could use the binary sorts out there. So that's the most optimal way to do. So we could use the same thing even for the 2D array, but there would be some small trick. That's it. So let's say this is a given, and we take this as an input, the same example as above, and we should assume that this is the 1D array, because I flattened the 2D array into the 1D, just like a plain one. And then based on this assumption, we could assume this as a we could use the binary sorts for this in this case, because that's the most optimal. So here, after we assume that, we need to know the length and the breadth of the 2D array. So here in this case, we would say row and the column. So once we have a row and the column of the given 2D array, then we could assume that as a 1D array, and then we put the left and the right. So the left always starts from the 0th index, and the right would be the last index. So since we flatten, so we have from 0 to 11 as our index, and the left is 0, and the row would be actually equal to 10, because in this case we have a row and column. The product of the row and column would be 3 by 4. All right, so hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So actually it should just be 11. And once we assume this, we need to use the binary sorts. So we have a pseudocode here, or we have a full code right over here. So we should use the while loop or the iterations such that the left should always be less or equal to the right. That's what we do, and then we find the midpoint. So mid would be the left plus right minus left equals to 2. So in this case, the mid would be 5, because I already wrote this value over here. And once we have a midpoint, in this case, 11 is the midpoint. So once we have a midpoint, we need to check where does the 30 lies. In this case, it lies on the right hand side, not on the left. So we can completely ignore the first half of the plain 1D array. So if we have to assume here, it's here on this index. So it's going to be 0, 1, 1, 1, 1. In fact, the row is 1, column is 1. So it's 1, 1. So to figure out that value, we need to use this equation. So matrix mid by column, and the mid present column. So in this case, we will have a mid as right now we have a 5, and the column is 4. So it's going to be 1, and same here, mid 5 and the column 4, and the remainder would be just 1. So that's a 1, 1. So in this case, 1, 1 would be 11. So we need to compare with the target. Is the given mid element equal to the target? So in this case, it's not. If not, then we do the same thing. If it is, then we just return found, or we could return just true. It doesn't matter, whatever you return. So if the midpoint is greater than the target, then if the midpoint is greater than the target, we change the value of the right. So the right would be mid minus 1, and if not, if mid is less than the target, then we change the value of the left. So mid plus 1. Then we just iterate through the other half, and at one point I think we will find the value somewhere on this section. On this section we will find the first would go here, even second would go here, and then at that point the target would equal to mid element. So I could debug this and show you in the program. So this is our program here. It's the same given, and then we have a given target as a 30 as well, and this is my program. Let me run first. So then I just return found because there is, it is. And if I put just 31 as a target, then I wouldn't find that, so it's like a not found. So let's get back here. Let me debug this. I put the breakpoint right over here. So let me, and we have a matrix as a 2D right here, and while debugging we could even see it as a flattened matrix, and we have a target here. So every time whenever we have this kind of equations or the questions, we need to check the base case. So the base case would be the length. If the length of the matrix is just 0, then we simply return false. That's like sending an empty array. We don't do anything for the empty array. Then we have a rows and columns. So rows would be 3, columns would be 4. So we have a columns here, rows here, and then we assign the left as a 0 and the right as a rows, product of rows and column -1. So in this case we have 11. And then we use the iteration while loop. So in this case left should always be less or equal to right, shouldn't exceed. So now we find the midpoint. So the midpoint would be 5, and the mid value would be this thing. So let me call the debugger. So we have a mid as a 5 and columns as a 4. So mid of divide by columns, so 4 divided by 5 in the form of integer would be just 1. And also in terms of remainder, it's simply 1 because we already know. So in this case the mid element would be the 1 and 1, right? So that's the 11 from the given matrix. So I remove this again, and then now we check whether the 11 is equal to target. So it's not. So now we check whether the mid element is greater than the target. So mid element is not greater than the target, it's a smaller. So we go through this loop, and then this case is true, so then we change the value of left. So once we change the value of the left not gonna be 0, this gonna be 6. So now we have a left as a 6. So now we only take care of the half of that. If we flatten here, then we just take care from 16 to 50. So remaining half we can completely ignore. So that's where we optimize the time. And then again, now we find the mid. So from 16 to 50, so 1 2 3 4 5 6, and then 1 2 3, so it's going to be 23. So the mid element is 23 now. So we ask if the target is equal to the mid element. It's not. Then we go to the condition, is the mid element greater than the target? Still no. So as I mentioned earlier, the mid element is smaller than the target. So now we change the value of the left again. So the left would be from 30 to 50, I guess. So we have a left value. The left is now 9. So we just need to compare from 9 to 11th element. And we take a mid value, and then we get the mid element. So the mid element right now is 34. So 34 is right over here, which is not target. So it's gonna check the condition, is the mid element greater than the target? In this case, yes. So we change the value of the right. So the right value would be over here now. So we'll just need to compare these two. So now we have a left as it is, right as a 9 again. So we are at the 9th point, and then we check get the mid element. So the mid element is actually 30. So is mid element equals to target? Yes. So simply we return the found, and then we have a value as a found. So that's it. It's pretty simple. It's similar to what you do for the binary search, except that there's one condition that we need to take care, is this one. If we didn't have this, then it could have been the same. There's other way to do as well. We could flatten. In fact, like right now we just assume it's flattened, and we are still using these equations to solve the mid element, but we could even flatten. So flattening may take O of row runtime. So just to avoid that, we are using this one. So that should be still fine. I think that's it. Thank you.